Jai Hind all. Myself Amita Asthana from Ajay Kumar Garg Engineering College, Ghaziabad. So, in this video lecture, we will take the topic from the subject Digital System Design KEC 302 as per AKGEC Lucknow syllabus. So, here the topic is flip-flop conversion. So, we have got 4 types of flip-flops: SR, JK, D and T. So, all the flip-flops can be converted to each other. That means if we want to convert SR to JK, JK to SR, T to D, D to T, JK to T, or let's say D to JK, and all these conversions are possible. So, how these conversions can be made and how the circuit can be obtained, what additional requirements are there, that we will see in this video lecture. So, let us just start with the example, that is, let's say we take an example for SR to JK flip-flop. Okay. So, for SR to JK flip-flop, we need 2 excitation table. Both tables for SR, also for the JK flip-flop. In the last video lecture, we have discussed about the excitation table, and these excitation tables are obviously derived from the characteristic table. So, we have got this excitation table. We will not go to the detail how these excitation tables can be written, but if it is better for fast computation at the time of examination, you should remember the excitation tables for the SR or JK or all the types. T and D can be simply remembered. So, here we have present state and next state. So, the required inputs are S and R, 0 0 0 cross 0 1 1 0 1 0 0 1 1 1 cross 0. So, 0 0 0 cross 0 1 1 cross 1 0 cross 1 and 1 1 cross 0. So, these 2 excitation tables we need to remember all the time whenever we are converting the flip-flop. So, here first point to be noted down, that is, we are having SR flip-flop. So, this particular flip-flop is available and this flip-flop is required, right? So, SR flip-flop is available and JK flip-flop is required. So, whatever flip-flop is available, we need to start from the available flip-flop. That means we need to start from SR flip-flop. So, first of all, we will write the excitation table for the SR flip-flop. Okay. So, here we will write SR flip-flop, and then here we will write present state, next state, and here we will be writing the J. So, we will write in this way. So, now coming to the SR, present state is 0, okay, and next state may be 0 or 1, okay, for present state 0. So, for in this case, present state is 0 0 and present state to next state may be 0 1. There are 2 possibilities, okay. So, 0 0 0 1, okay, 1 0 1 1, and so we will make a gap also, 0 0 0 1 1 0 1. So, if present state is 0, then there are 2 possibilities for the next state, that is 0 or 1. If present state is 0, again we are having two possibilities for this one, that is 0, 0. If this is 1, then there are two possibilities. Again for this 1, 1, we are having again two possibilities, 1 and 0. Okay, so this is how we write it, 0, 0, 0, 1, 0, 1, 1, 0, in this way. So we have 8 combinations. That means all the present state to next state switching, we have two possibilities. Now, write the excitation table for this flip-flop which we are having. So for 0, 0, the SR is 0 cross. We will fill. For 0, 1, the SR is 1, 0. For 0, 1, again it is 1, 0. For 0, 0, it is again 0 cross. For 1, 0, see, for 1, 0, it is 0, 1. For 1, 1, it is cross 0, cross 0. Right. So this part is complete. Now coming to the JK table. Here we are writing the characteristic table. Okay. So for 0, 0, present state is 0 and next state is 0. So JK for 0, 0, there are, see here coming to the JK flip-flop. For 0, 0, there are two possibilities, 0, 1 and 0, 0. 0, 0, so it is 0 cross. Okay, again 0, 0, so this is 0 cross. 0, 0, 0, like this. Okay, similarly here, what we can do is, since we are going to make the K map, so here we are not fill the crosses, because these we will select as our input variable. So we cannot put the 0 cross for this 0, 0. Should we write the 0 cross? Let us write, then you maybe understand. Just a second. See, if I write in this way, for 0, 0, I write 0 cross. 0 cross and 0 cross. Okay. For 0, 1, I will write 1 cross. Okay. And for 1, 0, I will write cross 1. For 1, 1, I will write cross 0. So I am repeating the entries. See, 0 cross 0, 0, 0 cross 0, 0. There is no use of repeating the entries, and it is difficult to make the K map from crosses because we don't specify K map as a cross. So I am having the option that what I can do is, for 0, 0, I will make it one as 0, 0 and another one as 0. Okay, similarly for this one, I will make 1, 0 and 1. Similarly for the two same entries, similarly I will make this as 0. Okay. Now the next step is take 3 as input variables and find the output for S and R. Okay, you need to find S and R. These are three input variables J, K, P, S. Okay. So now this PS you can take as Qn. Okay. So now I have three variables J, K and Qn, and I will make the K map for the same. So this is the table which we have got already. So all the tables I have written here. Now we can make the K map. So let us make the K map also here in this. So we will make a K map here. There are three variables, right? So the three variables are J, K, Qn. J, K, Qn. 0, 1, 2, 3, 4, 5, 6, 7, right? Now fill up the entries. Before filling the entries, let us analyze this one. This is for 0 and this is 4, this is 6, this is my 2, this is my 3 and this is my 1, 5 and 7. So they be very careful while making the K map, because at 4 and 6 I am getting 1, 1, 1. For 4 and 6 I am having, and more crosses for 1 and 5. So here I am getting 2 crosses like this. So I will make a pair for this one, and by easily, and if the crosses are left, leave them, no issues. So we can say that the S is equal to JQN bar. Okay. So for the S we have made this particular K map. For R similarly we will make this K map, and we will get S is equal to JQN bar and R is equal to KQN. Okay. So let us make the conversion. So we are having S okay, S is equal to JQN bar. So it is QN bar. So go to this. G. And R is equal to KQN. And this is the clock. We can clock, we must give it to this one. So here the JK flip-flop has been converted to the SR flip-flop. SR flip-flop has been converted to JK flip-flop. So the procedure is very easy. First of all, we need to write the truth table. Okay, the truth table will be written starting with the flip-flop we are already having, and write the excitation table for the flip-flop which we are having already, and then now whatever we need to make, we will write the characteristic table for the same, making the K map, filling the truth table and getting the expression, and then the realization. Now let us consider one more example to make this understanding better. Let us convert D flip-flop to SR flip-flop. So for D flip-flop conversion to SR flip-flop, So the procedure will be same. We will start with D flip-flop. Okay. So we will write characteristic equation, excitation table. We will write excitation table for this D flip-flop and characteristic table for the SR flip-flop. So here let us write, we will start from D flip-flop, QN, leave a gap, okay. Just we need to repeat the entries also, because the SR flip-flop will have two inputs, and then this is same as all we will write as, because Qn plus 1 is equal to D in this case. Now coming to the SR flip-flop, we will write the expression for the SR flip-flop also. All the SR to be 0 0, what we will write? SR to be 0 0, as already I told. SR to be 0 0, this is 0 cross, that is 0 0 and 0 1. So we have made the double entry 0 0 and 0 1. And similarly, one more 0 0 would be there. So here I think I just missed it, and 4 and 3. Okay, 2 0 0 also we need now. So we need to make 2 zeros also here. 2 0 zeros and 2 0 1, 2 1 0 and 2 1 1. So here this is 0 0 1 1 0 0 1 1, like this. So for 0 0 the SR is, for 0 0 the SR is 0 cross, that means 0 0 and 0 1 we will write. 0 0 and 0 1. Okay. For 0 1 again we will refer the table. For 0 1 we will have 1 0. Okay, so we will write here 1 0 1 0. Okay. For 1 0 again you refer this one 0 1 0 1 SR. And again it is for 1 1. For 1 1 it is 0 1 1. Okay. So in this way we can this, how I write it as 1 1. See, 1 1 is for 0 0 and 1 0. So 0 0 and 0 0 and 1 0 0 0 and 1 0. So in this way I can complete this particular table, and now I need to calculate for D in terms of the input variables, these S, R and Qn. And if I make the K map for S, R and Qn, so I am having 3 ones and 2 crosses, and I am having 1 pair and 4 entries, 1 1 cross, making a quad. So compiling the K map and getting the expression, we can just simply design D is equal to S plus R bar Qn. So here S plus, here we are giving a K or get to this D input, and here this is multiplied by Qn coming from here, Qn R bar, this Qn R bar is going to this one, and here the input is S plus Qn R bar. So in this way we can convert any flip-flop to any one, but just the simple steps from where we need to start and from where we need to write the characteristic table. So this writing of the truth table is very important, and similarly if you write it in a proper way, you can get the potassium. So once we will repeat these steps. So first of all, the requirement is the to learn the excitation table, and then just get the present state and the next state. Start from the excitation table of the available flip-flop. Write the characteristic table for the the required flip-flop. Make the K-map. Get these as output S and R. These three variables will be the input, and you can make the K-map and get the output. Thank you.